All right, so we have a 1 kilogram block that is attached to a spring with a spring constant 16 newtons per meter. While the block is sitting at rest, a student hits it with a hammer and almost instantaneously gives it a speed of 40 centimeters per second. What are the amplitude of the subsequent oscillations? All right, let's do this one. Part A. So we know from the problem that, let's list out our givens. Our mass is 1 kilogram. Our K is equal to 16 newtons per minute, and our V is equal to 40 centimeters per second. And we can just convert this right away to 0.4 meters per second. Since we know that, since we're dealing with kilograms and newtons over meter here, that's a pretty good indication that we're going to need to convert everything to SI units, so everything cancels properly. Now you might notice that this V doesn't have a V max here, and that's true. This should be a V max. And that's because that this is our maximum velocity. And we know this because the block is at equilibrium while we hit it. And when we hit it, we give it an instantaneous speed of 40 centimeters per second, which is a good indication that this, our 40 centimeters per second, is meant to be the maximum possible speed that the block can attain. And we know through our conservation of energy that our potential energy, what the spring, when it's at its maximum compression, is equal to the kinetic energy at the most possible amount, i.e. when the velocity is at its maximum. So we know that this can just be turned into 1/2 kx squared is equal to 1/2 mv squared. And we're going to add a little v max onto here. But wait, we know that even though this is our equation for potential spring energy, we know that this x has to be the maximum possible x, right? Because this is when it's at its maximum compression. So what we can do instead is take this x max and replace it with a, or the amplitude. Because the amplitude is just the maximum possible displacement of the spring from its midpoint. So therefore we know that this is just 1/2 ka squared is equal to 1/2 mv max squared. And this also helps us be handy because we want to solve for amplitude in the first place. So all we have to do is some algebra and cancel those guys out, and we got a squared is equal to mv max squared over k, and we know that a is an equal to square root of mv max squared over, it's a horrible 2, I'm sorry. Let me redo that. And this should be our final expression. And we know f